All right, welcome to The Explainer. Today, we are diving into a scientific theory that is, well, it's pretty out there. It's a theory that could completely flip everything we think we know about the history of Mars. We're talking a lost ocean, a captured moon, and a cosmic catastrophe so huge it's almost hard to wrap your head around.
Okay, so let's get right into it. The biggest single mystery about Mars, the one that has had scientists scratching their heads for decades, is this. Why is it a planet of two halves? I mean, it's literally split into two completely different worlds. And this split is so clear they even have a name for it, the line of dichotomy.
And when you look at the difference, it is just staggering. Seriously. The northern half, it's all smooth, low plains, hardly any craters, and a really thin crust. But then you cross over to the south, and boom, it's this ancient, battered, beat-up landscape. The crust there is on average 20 kilometers thicker. It's like someone took two totally different planets and just smashed them together.
And as if that whole split personality thing wasn't weird enough, Mars has this gash running across its surface, Valles Marineris. This thing is a canyon system so enormous, it makes our Grand Canyon look like a tiny little scratch in the dirt. We're talking a canyon that would stretch all the way from New York to California. And for the longest time, geologists have really struggled to figure out what could have possibly created it.
So here's the big question. What if the two-faced planet, that giant canyon, the monster volcanoes, the weird chemistry, what if they aren't separate mysteries at all? What if they're all connected? Well, the paper we're breaking down today proposes exactly that there's one single dramatic event that's the master key to unlocking everything.
And here it is. This is the core of the whole theory. Get this. The paper suggests that, for a massive part of its history, Mars wasn't even a planet orbiting the sun. Nope, it was a moon. A moon captured into orbit around a much, much bigger planet, a world they call Planet V, that might have existed out there between where Mars and Jupiter are today.
Now, being that close to a behemoth of a planet would have had some serious consequences. Imagine the gravity of Planet V just constantly pulling on Mars, stretching it, squeezing it like a stress ball. Eventually, that relentless pull would force Mars into what's called a tidal lock, where one side of Mars always faced its parent planet, just like how we only ever see one side of our own moon.
And right there, that's how the theory starts explaining Mars's weird geography. That constant gravitational tugging would have literally pulled the insides of Mars, its mantle, out into a gigantic bulge. And that bulge? That's the Tharsis Rise, the region with the biggest volcanoes in the entire solar system. And just like how tides work on Earth, you'd get a smaller bulge on the opposite side too, which lines up perfectly with another raised area we call Arabia Terra.
Okay, so what about that giant canyon, Valles Marineris? Well, the theory has an answer for that too. Before Mars got fully locked into place, it was still spinning pretty fast. And the paper argues that Planet V's immense gravity would have dragged the Martian oceans into a monstrous tidal wave, what they call a tidal bore, that would have just rushed back and forth across the planet's surface twice a day. Imagine a planet-sized wave just grinding away, widening a crack in the crust into the gigantic canyon we see today.
So this whole idea completely rewrites the timeline of Mars. It suggests that Mars was captured about 500 million years ago. And then, for more than 400 million years, it was this tidally locked moon with oceans until something happened. Something catastrophic right around 65 million years ago that changed everything.
And this is where the story gets really cinematic. We're talking about the day a planet died. The theory goes like this. A rogue planet, which they call Planet K, just wanders into the system. As it flies by Mars, its gravity gives Mars a good yank, tilting its entire axis, and then Planet K slams directly into Planet V. The collision shatters both worlds, right there in Mars's backyard.
The stuff flying off from that explosion, it wasn't just a bunch of random meteorites hitting Mars. No, this was a single, unified, planet-wide impact. The authors calculated the seismic shock to Mars was the equivalent of a Richter scale 15 earthquake. I mean, we don't even have words for that. It's a shock wave that would have literally vibrated through the entire planet, from the core to the crust.
Okay, a story this wild, a theory this big, it needs some serious evidence to back it up, right? Well, the authors argue that the evidence, the smoking gun, is right there in the Martian soil. The clues have been there all along, in the chemistry and the geology, just waiting for us to look at them in a completely new way.
And this is where the model starts to look really clever.
because it solves a bunch of chemical puzzles all at once. Like, why does Mars have so much sulfur and iron on its surface? According to this theory, it's because it got rained on by the core of Planet V. And why is the southern hemisphere covered in this mineral called olivine? Well, that came from Planet V's mantle, which blasted Mars after the collision. It also gives us this totally wild explanation for one of the strangest things about Mars, these weird magnetic stripes in its crust. The common theory is plate tectonics, but Mars doesn't really have that. This model says, no, that's not it. Those stripes are literally a photograph, a frozen snapshot of the cataclysm itself. The shockwave made the molten rock cool in bands, and as it cooled, it locked in the direction of the planet's magnetic field at that exact violent moment.
So think about this. What happens the second Planet V gets blown to bits? Its gravity just vanishes. It's gone. And those two massive oceans it was holding in place with that gravity, one on each side of Mars, well, they were suddenly let go, released all at once.
And this wasn't just some big flood. We are talking about a tsunami on a scale that is almost impossible to imagine. Literally, trillions of tons of water, suddenly free, rushing down from those high bulges of Tharsis and Arabia, and just scouring the surface as it poured into the northern plains. This is what the theory says carved the biggest outflow channels we have ever seen anywhere in the entire solar system.
So when you put it all together, what does this new history of Mars look like? Well, it's not the story of a planet that just slowly faded away and died. It suggests there was this long, stable period 2, what the paper calls a Garden of Eden phase, a Mars with a thick atmosphere, a protective magnetic field, and stable oceans. Basically, an ideal place for life to get started, right up until it all came to a sudden, incredibly violent end.
And just when you think it can't get any wilder, this is where the theory gets really provocative. The authors point out something strange. The key dates in their model just happen to line up, almost perfectly, with two of the biggest moments in the history of life right here on Earth. Mars getting captured seems to happen around the same time as the Cambrian explosion, when complex life suddenly appeared. And the destruction of Planet V, that lines up with the asteroid impact that wiped out the dinosaurs. Is that just a coincidence? Maybe.
Which leaves us with one final, absolutely mind-bending question. If this model is even in the ballpark of being right, it means Mars had a stable, warm, watery period that lasted for 435 million years. That is nearly twice as long as it took for complex life to show up here on Earth. So, what might have evolved there? What could have been swimming in those oceans in all that time, before it was all erased in a single catastrophic day?